and how does actually the architecture of different OS handles. So all these things we have discussed. And today, for the day, I'll be taking very less time because this doesn't have much more things to talk about it. Okay. So today we'll discuss about the embedded systems which we are using in mobile applications. So when I say embedded systems, like both the hardware and software, how it communicates to the mobile application and how the things moves on further. So we'll be discussing all of these. So do you guys have any questions on the previous session? Guys? If no questions, just tell me no. If you have, please proceed with your question. Okay, I believe there is no question. So today we'll be covering a few topics. Okay, first we'll discuss about the embedded software in Android, how it actually works. I'm just giving the agenda of what we're going to do today. For the first 10 minutes, we'll be discussing about embedded software in Android, and next we'll move on into hardware components, which is which is most important or most vital one in this hardware components in the Android devices. And next, you will be seeing the interaction between the embedded hardware and software, how the hardware and software is getting interacted, through which modem it's getting interacted. These things we'll see. And next on this, we'll have some kind of case studies which is running over, and we'll see about few of the development consideration which we have to think of when you are yet to decide or when you have decided to design a mobile application. Okay. So I'll just pin down the same thing in the chat box. Today I don't have the PPTs for the beginning few time. So first we'll discuss on it. I'm just pinning few of the contents, whatever I've discussed now in the chat box. Okay. These are the three core things which we're going to discuss for today. Okay. So the first one component which we have already discussed, but still I wanted to repeat it once again because it's a long gap which you might guys have forgotten. So I'm repeating it again. So embedded software in Android, there are three components. First one is your kernel, and the next one is your middleware, and the last one is going to be your device driver. Okay. So do you have any idea or you can remember any of these things which we have discussed in the earlier class? No one? Okay. Nobody is responding up. Fine. So embedded software in Android actually refers to a kind of software component which you can run all your embedded system within your Android application. So when you're talking about the embedded system, they are typically of hardware component responsible for some certain functions within the device, like managing sensor, controlling your devices, and handling communication protocols and all these things. In your Android, specifically in Android, the embedded software can include your device driver, firmware, and your low-level system software that can interact directly with your hardware components. For example, the software that controls your touchscreen, your camera, your GPS, or your Bluetooth model, in which the Android device would be considered as your embedded software devices. Okay. So developing your Android software for your Android, developing an embedded software for your Android involves various things of understanding which you wanted to have basic on your hardware architecture of this device. So without knowing your hardware architecture of the device, it is quite difficult for you to interact with those devices. So you should be flexible enough to write your code for hardware components, optimizing its performance, yeah, and its power consumption, and ensuring its capability. compatibility, and all these things within your Android operating system. All these things you have to consider. And the next one is going to be like your embedded software development for your Android that often requires a vital knowledge of programming such as C and C++. We should be familiar with their development tools such as Android NDK. So NDK nothing but your native development kit. So SDK, and also along with that, you have to also be little aware of what is NDK here, which is native development kit. Later we'll discuss more about this tool. I mean this kit. So this kit is basically used to write your native codes, your debugging tools for troubleshooting issues, and all your at your hardware levels. Okay. And in overall, if you see, this embedded software plays a very crucial role in your functionality and the performance of your Android device, enabling them to interact with your physical world, and also it provides a wide range of features and capabilities for the users. Okay, so I'm just giving a hint of what are things which you have to cover. Okay, it's very of top basic level. I'm not even going into a deeper one. I'm giving very lighter ones. Okay, so any doubts with this? Yes. Do you have any doubts or no? So whatever I'm discussing here, I'm just trying to put down the same thing in the chat box. If you're not able to follow up my words, you can also have a look on the chat box so that I'll be giving some hints of whatever I'm speaking in this chat. I did not have a presentation for today, so that's why I'm not able to do it. So next we will see about the further things of the software architecture which we have discussed. So the next we have to discuss on the components. So first one is going to be a kernel, followed by middleware and your device drivers. So all these three things we have to discuss for now. So without delay, we'll first start with kernel. So kernel is a kind of core for your Android operating systems. So this Linux kernel serves as a core. It provides you essential functionality such as process management, memory management, device drivers, and system resource handling. All these things, like there are a lot of algorithms written behind all these processes. Like if you guys have done with the syllabus of topic called OS, then you should have been aware of all these terms. So process management is nothing like you have a lot of algorithms behind it. It's like Blanca's algorithm, and you have uh, FS algorithm, and you have scheduled job algorithm. A lot of algorithms which is available, which will react upon the tickets which is comes in. Okay, and memory management is all about storing your data and organizing it. And device driver is about functioning your physical activity on the device based on the command which is provided. Okay. And in Android device, the Linux kernel will be responsible for managing its hardware resources, including your CPU, memory, storage, and various other devices. Okay, and the kernel facilitates communication between your hardware and the rest of your software stack, allowing the application to allowing your software application and its services to interact with the respective hardware through its standardized interface. So we'll discuss about the interfaces in the next sessions. So additionally, the kernel includes various subsystems like what is it, the support provided to a mobile specific hardware like touchscreen. So this is the roles and responsibilities of kernel, how it behaves. Okay. And the next one is going to be a middleware. So a middleware component is one which is responsible for establishing the communication between your high-level abstractions and your services. So that is like your communication, it basically facilitates your communication, management, interaction between the different software layers. Okay. When we talk more about Android here, so this middleware component, which includes multiple libraries, frameworks, and services that enables you to features such as multimedia, playback, your network communication, your graphical user interface rendering, and also your data storage. So for all these actions, Your middleware component has some certain libraries where you can just use it to establish all these activities. Okay. So you have a specific component, as we told earlier, NDK, which is native runtime kit. I mean toolkit. Same like that, you have Android runtime kit, which is ART, which is for executing your Java bytecode. And next you have Android Multimedia Framework, which is AMF for your multimedia processing. And you have Android connectivity and location APIs for handling your network and location-based service. So these are just a very commonly or very diversely used few of the middleware components. Okay, I'll repeat again. So first one is going to be ART, which is your Android runtime, and the next one is going to be your Android multimedia framework, and the next one is going to be your multimedia processing, and the last one is your Android connectivity and your location APIs. So all these are Android middleware, which is used to perform different actions like executing your Java code and your processing your multimedia files, and the next one is like to handle all your networks and location-based service. All these middlewares are used. Okay, and they are just like an abstract way. Okay, they are just abstract way from your low level of hardware interaction and provides developer with standardized API. So using the standardized API, you can build your application efficiently. So I have a separate concept for how this API works in mobile application. I'll come to that later. Okay, so this is all about middleware. So any doubts in this? Probably by now you should have a doubts in how this middleware work out. Please raise your questions. Still no doubts? Good. I believing that you guys understood it, so I'm proceeding further. Okay. And the next one you have your device driver. So this device driver is it is like enabling your operating system to communicate with your hardware device. So in Android, if you specifically see, so device driver are essential for enabling interaction between the various hardware components. So which includes your sensor, your cameras, your touch screen, Wi-Fi, Bluetooth modules, your receiver, which we use GPS, and many more we have. So all these things comes under the topic of device driver. So device driver is typically which will run within your kernel space, and it provides the interface between your high level software component to access and control your hardware functionalities. So basically device driver is one where it will be running on top of kernel. So using this kernel as its core, it will establish the communication between your hardware and software. So through your actions on software, it physically acts on its hardware devices. Okay. So next one is your hardware driver, which is often developed and specifically for your hardware component, which is used in your mobile application, which should be tailored as per your requirement. Say for example, if your memory is somewhere, I mean, if your battery space is somewhere between 2000 megabits to 3000, but if you are trying to have a high quality of camera or high quality of GPS, definitely it cannot support or it cannot run on its, what is it? It cannot run on its own function, because when these GPS comes into the matter, it requires a lot of battery. Okay, when your battery is not able to support, obviously there will be a glitch. Okay, so in order to that, you have to tailor all your requirements. So tailoring the requirements on your Android platform, which includes your power efficiency, your real-time responsiveness, and your compatibility between your hardware stock, I mean hardware software stack. So it is very core important to tailor your requirements. Okay. So this is all about your embedded software in your Android. So whatever I discussed now, which is typically about all your device layers of kernel, middleware, and device driver. Okay. So just to summarize you, so the Linux kernel provides you the system functionality that can manage your hardware device, and a middleware component facilitate the communication between your management of higher level service and the driver or device driver is enabling your interaction between the hardware device in the context of embedded software. So these components all together work to create a robust and a future friendly or feature rich platform to build your mobile application and its service. Okay, I'll just pen down all these things in the chat box. You can refer to it later. So this is your kernel. And the next one you have your middleware component and also your device drivers. Okay, that's all with this topic. And the next one is going to be your hardware components. So I don't think so. This requires me to speak much because all of you have an Android mobile in your hand. So I think you should be able to discuss about the hardware components. Can I have someone in this call to explain or to just say what are the hardware components which is running in your Android device? Can someone do it? Can anyone? Or you want me to pinpoint the names? Nobody? Can I have Karthik, yes, to speak up if you don't mind? Anybody? Just speak out, guys. It's like one way communication, which is not going to work out. Nobody's ready to speak up. Why, guys? Am I boring the early morning? Okay, so I'll take up. So when you discuss about your hardware components in your Android device, there are many more hardware device which I'll discuss few of them. Okay. So first thing is your processor. So processor, and the next one is going to be a memory, and your storage, your sensors, your connectivity devices, your display, and your battery. So all these are your few of the hardware devices which is available. So when you talk about processor, so Most commonly used processor are ARM based processor, which is manufactured by Qualcomm, MediaTek, and like in case of Samsung, they own their own Exynos series. So mostly they manufacture ARM based processor. So again, what is ARM based processor? These are some interesting topics which all of you know and all of you are using day to day. So when you talk about ARM based processor, this is like again a microprocessor which is basically hold all the ARM holdings, and it is most commonly used for IoT kind of devices, and it is used in tablets, smartphones, and all these things. Here, the architecture is all about RISC, so which stands for Reduced Instruction Set Combined as or set computing. So it is with very minimalistic of instruction, it can be able to do its work efficiently. Other than like complex instruction, we have another architecture earlier which is running, which is called SISC, which stands for complex instruction set computing, which was now get demolished, or I can say it is not demolished, but it was usage was get reduced because of this RAC, because RAC is able to work far better than his MISC, so it was out in the market now, and it has a greater energy efficiency, and it has larger amount in scalability, and it works very perfectly for customization and your licensing model. And on top of this, if you talk about the performance of ARM based processor, it is very well known for its energy efficiency rather than its raw performance. So higher performance ARM cores, which is like Cortex A. So this Cortex A you might have been heard in multiple domains or in multiple locations wherever. So this Cortex A series was ruling the market quite long, and they are like traditional x86 processor. And in terms of performance, especially for mobile and embedded applications, Cortex A is the best one. Okay. So if you see why is it out in the market, because of its scalability and customization. So and their innovation. So they are like again open license tool. They are kind of open license model which encourage your all your innovations and your competitions of your semiconductor companies. So Samsung is one we are competing with this with their Exynos top model. Okay. And the next one is about graphics processing unit, which is GPU. So GPU is again produced by Arduino and your Mali, which is a company, and you have a Power VR. So all these three are kind of companies which will much focus on their captivating marketing on a GPU. So Qualcomm is one which is sponsoring their Arduino, and Mali is one who are manufacturing their ARMs, and Power VR is one who is manufactured by Imagination Technologies. Okay, so what is the use of GPU? They're always responsible in rendering your graphics, handling your video playback, and accelerating your graphical tasks. So for all these things, GPU plays a huge role. And next one you have your RAM, which is random access memory. So here it is a kind of temporary storing data and executing all your programs. It again plays a crucial role in when you talk about multitasking, your split screen activity, and the background application. So to in order to have a seamless connection, it is advised to use your RAM, a best one RAM. So we always suggest a RAM ranging between 8 GB. Nowadays, 8 GB is be the minimalist one. At least 4. Okay. So 4 GB RAM, 16 GB RAM, and many more, depending on your device price and your budget. So you can decide your RAM, and based on your RAM, decide your GPU. So both should be compatible so that you will have some good features. Next is your storage. Storage is a kind of non-volatile memory where you can store the operating system, your system files, your user data, and all your installed applications. So Android devices using a various types of storage such as embedded multimedia card and you have universal flash storage, and the newer technology is like non-volatile memory express. So have you ever seen any mobile which has this?
No, sir.
None of you guys are aware of it. Basically, if you see, there are some 3 to 4 mobiles which is in the market, but still they are not widespread, it seems. Okay, so they once they come to the market, definitely they'll rule it because they have very high speed of SSD, which is solid state driver, and it is typically being it is first planned to go with tablets, and then it will be coming for their Android devices. So that is how the market is ready to go now. So this adoption of this NVM, which is non-volatile memory storage in smartphone, it is it is just starting to emerge in the market. So manufacturers are continuously pushing its boundaries in order to have your storage technology to improve your read and write speed, reducing your latency, and enhancing your overall experience. So this will definitely rule. Mark my words, it will definitely rule the market once it is being popularized. Okay, and next we have displays. So at least you should be knowing UFS. I did not want to cover much on UFS because this universal flash storage. UFS is nothing but your universal flash card, which all of us have in your laptops. Okay. So next you have your displays. So when you talk about displays, we have LCD, OLED, AMOLED, and all these are still improvising. So LCD is nothing but a liquid crystal display. OLED is organic light emitting diode, and AMOLED is your active matrix organic light emitting diode. So if you see LCD earlier, it was not able to handle the battery effectively because the the memory or the power required to emit those light was bit heavy. So they went on OLED so that you're using your anode and diode cathode, where you can minimize your battery compaction. And then after that, they were again moved to AML. So using this AMLOED, they were used to cut down the memory consumption and reduce the emission of your blue light. Okay, and nowadays the TV, desktop is all getting evolved on top of AMLOD. It rules the market now. Any doubts still here? No doubts. If no doubts, we will move to the next topic, which is touchscreen and sensor. So can someone talk about touchscreen? How does it actually works? Or else, what are the different types of touchscreens you have? Can anyone? Nobody? Okay. So basically, you have some different technologies which is called captive speed touchscreen, or resistive touchscreen, and there are new technology which is like in display fingerprint sensors. So basically, all these touchscreens which will work based on the okay. Yeah, back a message like I understood that you guys are facing some mic issues. Fine. So there are a lot of devices which is mostly used in ARM processor, which IoT device will use. So this specific GPU model is available for Android or not? It is available. There are few specific GPU model which is available. So you can also, what is it? You might have seen many Arduino microcontroller which is typically incorporate with your GPU unit. So it is available. So while these Arduino board themselves, they themselves do not have a specific GPUs, but it is possible for us to interface them with some external display modules. So or you can add some graphical controllers to add your graphic capability to Android project. So these external modules will include all the display types and TFT screens. Additionally, these microcontroller platforms, no, which is very similar to Arduino, they offer more advanced graphic capabilities, such as like if you guys are aware of Raspberry Pi Pico, which has RP 2040, I guess 2040 microcontrollers. So they are like strictly a GPU module where this RPO 2040, which includes features like IO, which is input output PIO, where the state machines that has been used to implement your graphic acceleration, and it also acts as interface within the displays. Jack, have I answered your query? Just comment down. You can comment down. Jack, I think you have answered your query. If you still have doubt, please feel free to ping in the chat. Okay. To again make you a summarize, uh, we don't have specific GPU module which is available within Android, but within Arduino, but it is possible for us to incorporate it. Okay. So continuing to the next one. So the next we have your so sensor, all you know, like we have auto rotation, we have light adjustment, like dark mode, switching to mid, little darker, extra dark, and light mode, and GPS navigation and your fitness tracking. So all these are possible because of multiple sensors which we have in the device. Okay. So if you see about what are the sensor which we have, see, like for accelerometer you have, gyroscope you have, ambient light sensor, and your GPS receiver, magnometer, and your barometer, and your heart rate sensor. So these are different sensors. Like we'll leave one by one. See, accelerometer is one which is used to detect your device orientation, which is landscape or portrait. So depending on that, your portrait mode or landscape mode will fix. So this is the one sensor. And gyroscope. So gyroscope is used to measure your rotation of your device or your angular velocity, they say. So depending on this angular velocity and your rotation into the axis, this gyroscope will be able to send the data. So using this data, it will be finding out all your navigations. Okay, so it quite works with AR, which is augmented reality. It quite works with that. It enables smoother and auto rotation, and it improves its accuracy as well. So next you have ambient light sensor. So this ambient light sensor is used to measure the intensity of light which is falling on your device within the environment. So used for automatic brightness adjustment and for display or optimize visibility and conserve your battery life, this ambient light sensor will be used. Okay, and it helps in providing you an optimal viewing condition for adjusting your screen brightness. And next is your GPS receiver. So GPS is nothing but global positioning system. So this receiver uses a signal from the satellite to determine its device geographic location. So it is very essential for navigation to use your map, direction, and also location tracking. So it supports various applications like such as like turn by turn navigation, geo tagging of your photos, and your location based reminders. So all these things works based on a GPS receiver. And next you have magnetometer. So magnetometer is used to measure the direction between your magnetic fields. Okay. Next is a barometer. Barometer is used to measure your atmospheric pressure, like your rainfall, uh, climate changes. All these things will be able to detect using a barometer sensor. So your altitude information and enhance your accuracy of your GPS. So barometers doesn't work individually. It works along with GPS and what is that? Gynoscope. All these sensors are dependent or they don't work separately. They work collaboratively. And you have heart rate sensor to understand your change in blood flow and your pulse rate, your oxygen level, and it helps to track all your cardiovascular health and optimize your workout. I mean, you can use it for your optimizing your workout intensity. So these are few kinds of sensors you have. So all these sensors will work for its individual capabilities. And next you have connectivity. So connectivity component enables you the communication between the device and your external networks. Like you have how do you establish this? Like you have your Wi-Fi, Bluetooth, near field communication, and your cellular data like 4G, 5G, and the GPS and USB connectivity. So these are like communication platforms where you can use these platforms in order to communicate your data from one layer to another layer. And last but not the least, you have camera, which allows you to capture some photos, videos, and all these stuff. So in Android device, the features primary camera which varies resolution as like front facing and your back facing cameras. All these are some enhancements which came up in the recent years. Okay. What about to answer Shyam? What about Apple Vision GPU and processor? How does the okay? Before going to the next question, you wanted to know Apple Vision Pro's GPU and its processor. See, Apple it owns their own what to say. They have their own sensors and the processor, which is not they don't sell it from other vendors. So there is a device called Apple Vision Pro that is possible in having their own uh, GPUs. So if you talk much more about these GPUs, no, there is a unique specialty of this GPU. They have a separate chip which is called M2 chip. So this M2 chip, no, there are a lot of capabilities. They were having some different storage configuration. They were the one which they introduced different types of memory location. So in earlier, if you see, there were only two layer of communications, I mean two layer of storage configuration. But here in this M2 chip, they were able to have three internal storage configuration, which was each for like around 256 GB and till 1 TB, I guess. Okay. Did I answer your question? What about Apple Vision Pro GPU and processor? Yeah, I think I've answered you, Shyam. If you're still doubted, and if you want still more definition of it, please ping me. Share in this chat. Thank you. And water level sensor, to answer Jack. See, this water level sensor, it is used, but how is it exactly used in mobile devices? It's something different. See, basically, water level sensor, there are a lot of sensors to detect your water level. But if you are more into the water sensor which is available in your mobile is um, it is a kind of, I'm not remembering the sensor name exactly, but there is a sensor which is very minute in size, very minute when you compare to other sensors. It is very minute sensor which we have, where it will detect the water level which is entered in your mobile. I think it is something called hydrostatic or something. I don't remember the name exactly. I think it's kind of hydrostatic pressure, which it will be able to identify the level of water, the density of water which is available, which is being entered into the mobile. So there are some different working protocols where it will see already your device will have some fluid inside the device, which will be very thick density. So, but the water's density is a little different. So, when this water from outside Earth, which enters to the mobile, it will compare the density between the fluid which you have in the mobile and the fluid which you have in the which came from external source. So, using this comparison, it will find the amount of water which is coming. So, depending on that, there are a lot of calculation they do, and that is how it works. Okay, Jack, have I answered your question? Jack. So after your question, I just think I wanted to pinpoint one more added point. So on top of your water level sensor, you have something called your moisture sensor. Okay. So what is the use of moisture sensor is, we know in market people says that they buy the mobile and very in 1 or 2 days when they wanted to read, they'll say that the actual cost would be they would have dropped the mobile inside the water, but they'll try to pretend that they have not thrown into water. Some other issue they would present. But how do the people understand, or how do people come to a point? I mean, the technicians I'm talking about. How do they come to a point that they will be able to understand whether it was dropped to water or not? It's like using this moisture sensor. So this moisture sensor, it is a kind where it will be able to find the cooling level of the mobile. So once it is bit, once it is the water is entering into the device, they will be able to find out what was the actual cause. So according to this, the technician will be able to determine whether it was actually caused by the water or not. So the next topic we have. So this is going to be my last topic, embedded software interactions. So as can I read the inputs of digital and input? See, it is possible. You can be able to read your digital and analog inputs from the same port, but but there is a checkpoint like not all microcontroller microprocessor has this ability. There are some certain microcontrollers where you'll be able to configure the functions of both digital and analog inputs and outputs, while other functionality can be mixed between each and other pins. So if the microcontroller is supporting both digital and analog functions the same pin or port, you technically need to configure that particular pin port more appropriately. It's basically of how you design your equipment. So if you see, they don't give it. Maybe now is it, but the long period was not there. But if you want to read both your analog and digital in a single port, then you have to design your port accordingly. Okay. So, for example, if you want to configure a pin to operate mode to read your analog voltage, which is used in a converter, and then if you wanted to switch to digital mode to read digital, and then you can switch it to a digital mode by having your digital signal, which means in that port you can have a condition for the another connectivity. So using that connectivity, you can uh, whether that port has to read analog to digital or digital to analog. You can have an external pin or you can have an external port. To that port, you can control the port which has to read analog data or digital data. If you ask me, yes, it is possible, but not at the same time. At a time, you can read either analog or digital. If you want to read as analog, the switch has to go on AC. If you want to read it, then the vice versa. That is how it works. Okay. I answered your question. Yes or no? I believe that it's yes. If you still doubt, please raise your hand or just put in this comment box. I'll reply back. How to communicate Raspberry Pi and Android Arduino microcontroller? Okay. Um, okay. You have the different kinds of communication ports. Okay, which you call SPI, which is serial verifical interface, and you have UART, which is again for serial communication, which will be communicating between Raspberry Pi and Arduino. So both Raspberry Pi and Arduino is using a universal asynchronous receiver and transmitter. So this hardware allows you to communicate your transmit, which we call TX, and your receiver touch pins. Okay, so this UART is one used for communicating the channel which we mentioned. So you can connect your terminal pin, I mean your transmitter pin to one of the device and the receiver pin to another device or vice versa. And the serial communication is easy to implement and it is very suitable for transferring small amount of data. Okay, when you wanted to share or if you wanted to transmit and receive a huge amount of data in very high speed, then it is preferred to go with serial verifical interface. So this is synchronous. The other one which you use asynchronous, but there is SPI is synchronous serial communication, which is the communication between your microcontrollers, sensors, and other verifical devices. So while Arduino supports SPI natively, Raspberry Pi will be able to communicate using your through its we have a pin called GPIO. Okay, so this using this GPIO pin you can communicate possible, which is called general purpose input and output pin, which you can communicate your transactions. Okay, and then we have four wires, which we call master out slave in, master in slave out, and serial sock and slaves select. We call slave select or slave sock. So using all these four wires, you can establish the transaction between the Raspberry Pi and the Arduino, which we call SPI. Example: there are different microcontrollers communicating the same input. So, okay, to answer the next question, there are different microcontrollers communicate with same path as possible or not. Yes, I told you, it is able to communicate with same, but the check here is when communication is happening, you can have a port externally designed to enable its action of how to work. Say for example, if you are something as analog, if you wanted to convert as digital, then you can make your port to work in such a way. But if your port has to work by itself, if the input is digital, you have to convert it to analog, then you have to manually go and change the design of the port. Okay. So example as Raspberry Pico and ESP8266. It is possible. I won't say this, it is possible, but you have to have some exception conditions there. So without the exception conditions, you will not be able to. So when you ask me like how to it means, like you can connect your U.tx transmit pin to your I mean what do you say? Connect your transmission TX transmit pin of your Raspberry Pico to your AX pin of your ESP8266. So whatever microcontroller you're talking about. So first take your pin, which is transmission pin on Raspberry Pico, and set it to the ESP8266 receiver pin. So after this connection is made, both the device is able to have a common ground connection. So then you can program your S3 PA to act like U.master and start sending your commands or data to the microcontroller, which is ESP8266. Now program your ESP8266 to act like you are other pins. So let your ESP controller act like your receiver, which will act as a slave. So receiving all its commands or data from the Raspberry Pi. Okay, this is a connection. And next, talk about interface. Implement a user. You want to implement a user interface for Raspberry Pico using a programming language. It's Java. And user interface can include your button, slider, text box, and all those things. And use some standard library which is in Python, like Lightner and PyQt, we call PyQt to create user interface. So user interface will create in your library which you have in Python. And then communication, you have to define your communications protocol in the data in Pico and the microcontroller which we mentioned over its UART. For example, say you want to come page to the controller function as Wi-Fi network or something or HTTP request or really your sensor data, you have to enter code. And in the implementation phase, you have to write a firmware for both Raspberry Pi and USB to handle its communication, which we are in the second step. So after the communication is done, using a Raspberry site and using your MicroPython or any of SDK whichever you're using, you handle your communication to perform its action. So use your Arduino IDE or your IDE you call. You can handle your communications and you can use the communication functions. So I can next integration. Integration what it is using this firmware connection between the two devices and your Pi serial, which is used to send and receive data over the UART Raspberry. You can establish this connection. This is a huge step. Yes, we can do it. So I think that should be clear with this now. If it's still doubtful. Any doubts? That's it. We have done for the July sessions. If you have any doubts, I'll be waiting for the next 5 minutes. You can post your doubts. If now we can have the session. So before that, I want one help. Like the next session, we are going to discuss about interacting with your UI. So many of you are comfortable in which programming language. So depending on that, I can decide the programming language the session to be. Java or Python. So which language you want? Please comment on that. We'll do the next session. The next section is like interacting with the UI. Nobody's going to answer. I would prefer to go with Java. And I was working with Java quite a long time, so I'm comfortable with Java over Python. Because in my part, I generally use Java. So I have to go with this. So thank you, Jack and Sham, for keeping the session intact. Thank you so much, and thank you for others who were able to make up your time to join the session. So next session we'll be discussing on interacting with your UI elements. So this interaction, so I would request you to go through a few of them because uh, this will play a huge role when you go for the next thing. Okay, this will play a huge role when you go for the further sessions. Okay, so please make sure that you please brush up before you come. Okay, so we'll be covering off how do you enable the inputs to the user data, how do you navigate through the screens, how do you view the information, how do you perform action using various UI elements such as button, text field, slider, and all these stuff. So next session, I mean, we will go with practical one. I'll install all the requirements whichever I want. And one more question, like, do you guys wanted me to project or to present the installation steps as well, or we can directly dive into the session? Because if you wanted me to present or give you the step-by-step procedure for installation, then I have to uninstall the application which I have right now, and then I have to install. So do you guys want me to do that, or will directly dive into session you will be capable enough to install yourself in your machines? How do you want it to proceed? Okay. Back out. We can do it. Thank you so much, guys. Thank you for your time. I'm running out of time. Thank you all. Thanks. Have a good day. Bye bye.